Hello everyone. Elevator carries on the material transportation. It begin to stop when rising to upper limit B. It begin to stop when descending to upper limit A. Using normal reverse and forward to carry out the up and down movement, reach the corresponding limit and then press the stop button will find that positioning is not accurate. This task will use PLC to achieve position control. First, I/O address distribution. Traditional relay contactor control can be used to solve the problem of upper limit stop and lower limit stop inaccuracy. As shown in Figure 1, the upper limit position switch SQ1 is used in the control circuit to disconnect the KM1 branch and the rise stops. The lower limit position switch SQ2 is used to disconnect the KM2 branch and stop the descent. It is called the position control. I/O address table of PLC can be obtained based on circuit principle. Input. Input device is start button SB1, function is start, input relay is I0.0. Input device is start button SB2, function is start, input relay is I0.1. Input device is stop button SB1, function is stop, input relay is I0.2. Position switch is position underscore switch underscore SQ1, function is stop, input relay is I0.3. Position switch is position underscore switch underscore SQ2, function is stop, input relay is I0.4. Output. The output device is contactor KM1, which is used to control the motor, and the output relay is Q0.0. The output device is contactor KM2, which is used to control the motor, and the output relay is Q0.1. Second, PLC external wiring. The terminal L plus M is connected to a 24V DC power supply. The stop button selects the normal close contact, the start button and the position switch selects the normal open contact. Position switch can also choose proximity switch, which is contactless position switch. Position signal can be obtained easily. The I0.0, I0.1 and I0.2 terminals are connected with corresponding buttons respectively. The I0.3 and I0.4 terminals are connected with corresponding position switches respectively, and the other terminals are connected with 1M terminals through DC power supply. The contactor chooses DC contactor. The terminal 4L plus 4M is connected to a 24V DC power supply. Q0.0 connect with KM1 coil to the power supply negative, Q0.1 connect with KM2 coil to the power supply negative 2. Third, design the program. Forward and reverse are continuous operation. First, design two program to achieve one-way continuous operation. The two output coils of forward and backward rotation cannot be connected at the same time and are interlocked through the normal close contacts of the output relays. SQ1 normal close contact automatically cuts off Q0.0 coil branch and SQ2 normal close contact automatically cuts off Q0.1 coil branch to realize position control. The normal open contact used in the position switch for hardware needs to be normal close in the program, and the connecting branch meets the requirements. Program input. 4. Program input. Hardware configuration is carried out first. Open the TIA portal software, switch to project view. Create a new project, project name, position control. In the project tree, select Add New Device. Click Controllers Somatic S7-1200 and select CPU 1215DC/DC/DC, Article No and Version. Article No and Version. Click on Profinet Interface _1, click on Add New Subnet, set IP address in the project. Click Add New Subnet and set IP address in the project. Open PLC tags and click Add New Tag Table. Start _button _SB1, data type bool, address I0.0. Start _button _SB1, date type bool, address I0.0. Start _button _SB2, data type bool, address I0.1. Start _button _SB2, date type bool, address I0.1. Stop _button _SB3, data type bool, address I0.2. Stop _button _SB3, date type bool, address I0.2. Position switch SQ1, data type bool, address I0.3. Position underscore switch underscore SQ1, date type, bool, address, I0.3. Position underscore switch underscore SQ2, data type bool, address I0.4. Position underscore switch underscore SQ2, date type, bool, address, I0.4. Contactor underscore KM1, data type bool, address Q0.0. Contactor underscore KM1, date type, bool, address, Q0.0. Contactor underscore KM2, date type bool, address Q0.1. Contactor underscore KM2, date type, bool, address, Q0.1. Input the program and click Program Blocks to open the main OB1 program editing page. Design two self-locking program branches through normally open contacts and output coils, and set the corresponding addresses. Interlock protection is realized by the normally closed contact of output relay. The normally closed contacts of SQ1 and SQ2 are connected in series on the branch for position control. After the program is written, click Compile to check the compilation information, and modify it in time if there is any error until there is no error. 5. Program Simulation Verification. Click on the Start Emulation button to load the program, start the module, and turn on the program monitor. The green contact indicates on and the blue dotted line indicates off. Open the factory I/O simulation software and click on Start Simulation. Start and stop buttons are provided on the control cabinet door, and upper and lower limit position switches are provided on the elevator. When Start underscore button underscore SB1 is pressed, Q0.0 is turned on, SQ1 signal is detected, SQ1 normally closed contact is disconnected and Q0.0 is disconnected. When Start underscore button underscore SB2 is pressed, Q0.1 turns on, SQ2 signal is detected, SQ2 normally closed contact breaks, Q0.1 breaks. When Stop underscore button underscore SB3 is pressed, Q0.0 and Q0.1 are disconnected. When Start underscore button underscore SB1 is pressed, the elevator rises and stops automatically when it reaches the upper limit. When Start underscore button underscore SB2 is pressed, the elevator descends and stops automatically at the lower limit. Here are some exercises for this lesson. The above content is how to use PLC to achieve position control, focusing on I/O address allocation. PLC peripheral wiring, program design, program input, and program simulation verification. Thank you all.